Well, hello, my algebros. Here we go. Getting ready for our Chapter 8 test, right? So we're going to go through some study guide solutions, but we're also at the beginning of class, if you've already had the solutions going over, you know that we checked our quizzes from last time. You can always pause and zoom into that screen if you'd like. But here we go on the study guide. So on number 1, we see that first of all of our equations are ax squared plus bx plus c when it equals y. It's always y equals to figure out the function, right? And when we set the equation to equal 0, we're solving for those x-intercepts when y is 0. On question number 1, it says, what are the solutions to these two things that have been factored when they equal 0? So we go ahead and solve for each one when they equal 0. So x will be 3 over 2, and when we subtract, we get x is negative 7. So our two x-intercepts are 3 over 2, or 1.5 if you use decimals, and negative 7. On number 2, it says solve by factoring. So on number 1, it was factored for us. But number 2, we have to factor, and we're going to use Xbox. Two numbers that multiply to be 27 and add to be 12 will be 9 and 3. So we know it's 9, x plus 9 and x plus 3, and then we solve when they equal 0. So we have to subtract the 9 and we subtract the 3. So our answers are going to be negative 9 and negative 3. On number 3, we would love to factor this first, and it's kind of set up like we're going to do completing the square, but first we're going to check it by moving it into standard form. We add the 10 to both sides, so now that it's in standard form, and we see, can we Xbox this? Are there two terms that multiply to be 10 and add to be negative 7? And of course there are. Negative 2 and negative 5. Now we solve for these when they equal 0. So we'll get positive 2 and positive 5, right? Because we solve when they equal 0. That is how we got those two numbers. Okay, next, the instructions. Don't forget, all of the quizzes and tests go in the order of which we learned. And it literally starts with the basics and moves you up to the harder concepts. So then we started to think about when we were factoring, is there a shortcut we can take? And we remember our twins. We have identical twins and opposite twins. When I have opposite twins, there's no shared closet, or there's no bx, right? Which means we can solve by square rooting. And the instructions tell us, solve by rooting. That means we isolate the square by using SADMEP, right? We subtract first, then we divide, and we finally get to that e where we can use our exponents, and the opposite of squaring is square rooting. So we get a equals plus or minus 4, right? Or positive 4 and negative 4 are two values, because with no bx, that means that the vertex is going to be right on that y-axis. All right, number 5 is also a perfect square, but these are identical twins, x plus 7 times x plus 7, which we don't need to factor out and go all that way. Instead, we just use this shortcut and solve by square rooting. Now, I have to decide, do I want to use a decimal for 12? The square root of 12 is not a perfect square, but I'm going to go ahead and use the simplified radical because I believe it's easier. Plus, we do it in the next chapter. So I look at 12, and 12 is 4 times 3, and 4 is a perfect square. So I factor that out, leave 3 inside, and then all I have to do is isolate my x by subtracting 7. So I get x equals negative 7 plus or minus 2 square root 3. Now, of course, you could have chosen to do a decimal, and the square root of 12 is 3.5. So you would take negative 7 plus 3.5 and negative 7 minus 3.5, and you could get negative 3.5 and negative 10.5. Same values, just looks a little bit different. All right. Next, we have that next step. Because we love solving by square rooting, because it's so much easier, we are wanting to complete the square or make it a perfect trinomial. So when we look at this question, it's only asking you, how could I make this a perfect trinomial? What would I do? And I take that b value, I cut it in half, and then I square it. So our answer here is I would square 4, which means I would have to add 16 to both sides. That is my answer, would be 16. Which leads us into number 7, which says solve by completing the square. In order to do this, our first step is to make room to complete the square. So we move the 32 to the other side. Then we cut our b value in half, we square it, we add it to both sides. We created this new perfect trinomial, c plus 6, and negative 32 and 36 is 4. We solve by square rooting, and we get c plus 6 equals plus or minus 2, and we isolate the c, subtracting 6 from positive 2 and subtracting 6 from negative 2, getting negative 4 and negative 8. Number 8 asks us to solve by the quadratic formula, which you all know by your beautiful songs now what it is. Our negative b plus or minus the square root of b squared minus 4ac all over 2a. And you substitute in after you've identified the a, b, and c, right? So we identify our a, b's, and c's. And then we look inside that root bar. We have to make sure that we're going to do our exponents. Then we multiply before we add or subtract. So we just have to make sure we're PEMDASing correctly after we substitute. So I go ahead and substitute in, and I get negative 3, that's my b value, plus or minus 3 squared is 9, minus 4 times a, which is 1, times c, which is negative 28. And negative 4 times negative 28 is positive 112. So I add that to 9, getting, again, I must multiply before I add it to it. And a negative times a negative is a positive. Really got to watch that pre-algebra skill. Then 2 times 1 is 2. That's why we're dividing by 2. So then the square root of 121 is 11. And we get negative 3 plus 11 divided by 2 and negative 3 minus 11 divided by 2, which gives us 8 divided by 2, which is 4, and negative 14 divided by 2, which is negative 7. Feel free to slow down the video or pause it anytime you need, or to rewind it or whatever, okay? All right, now we get to choose. How do we want to solve these? So I have to look at the equation first. Number 9 shows me there's no bx, so I am going to isolate my square, my perfect square, by using SADMAP, and I see that I can just solve by square rooting, getting plus or minus 4. Super nice. I could also just take out a GCF, because that's always a good thing to do. And when I do this, I could still isolate my x squared, and I still get plus or minus 4. On number 10, knowing that dividing off a GCF is always the number one thing I want to do, I did that, took out a GCF, and then I see it's a simple Xbox method at this point, where I find that it's negative 1 and positive 4, and I solve when they equal 0, getting negative 4 and positive 1. Of course, I could have also done AC method if I wanted to. Two numbers that multiply to be negative 16 and add to be 6, which would be positive 8 and negative 2. Then I felt I would factor by grouping, regroup, take out a GCF, and I'd still get negative 4 and positive 1. All right, number 12 is my first word problem. And on this, I always like to graph things out. We know our equation is always y equals. Now it's saying h equals. So then y-axis must be h, because it says h equals instead of y equals. It also says that our x value there represents time. So I'm going to say that the x-axis is time. And it says that it has no c value, which means that it starts on the ground right here. Because if I had no c value, that means there'll be like plus 0 here, which means this ball is going to start on the ground and it's going to go up in the air and land on the ground. And the question is, how long will that ball be in the air before it lands again? So when it hits the ground, that's when the height is 0, right? And we go ahead and factor out a GCF. And I factor, so negative 18x, when it equals 0, will just be 0. And then I factor out x minus 3 when it equals 0. And I solve for that and I get 3. So it's 3 seconds that this ball was in the air, right? On number 12, when it asks to solve for the 0, they're talking about when y is 0, right? When y is 0, we're always going to be looking for those x-intercepts right here. So we go ahead and look at the graph. They're right on there. We can see it's going to be 2 and 5, right? 2 and 5. And what does that tell us about this? It means that the solutions were 2 and 5. So then the equations, when they were equal 0, must have been x minus 2 and x minus 5. So that tells me I could multiply these back out like we did in chapter 6 and find the equation of the line, which would be x squared minus 7x plus 10. Alrighty. On number 13, I can see that if the A value is positive, then it makes a happy face. Since the A value is 2, we know that it moves upward, right? And since the A and has a minimum. On number 14, the A value is negative 3, which means it has a maximum. Right? Just a little reminder of these concepts over here. If I was using my equation, y equals ax squared plus bx plus c, if the A value is positive, it always makes a happy face, which means it has a minimum. And if the A value, it's also going to be for the minimum or maximum, it's going to be y is greater than or equal to whatever the y is of the vertex. Versus if it's a negative value, then it's going to make a sad face, which will be a maximum. And on the vertex, it will be less than or equal to that value. Which leads us to number 15, where we find the vertex here, which is 2, negative 4. And because of that, I know that the minimum value, because it is a positive equation, will be negative 4. Or the lowest that it can go, the minimum it can go is negative 4, but it has all the positive infinities. On 16, it tells us to find the vertex from an equation. So that means I use a negative b over 2a to solve for my axis of symmetry over here. And I substitute in b is negative 10. So I have a negative 10 divided by 2 times a, which is 5. That gives me 10 divided by 10, which is 1. So now I know one part of my axis of symmetry, or the x value of the vertex, is 1. To solve for y, I always substitute into the equation because it says what y equals if I only had an x. And now we know x is 1, so we substitute in when x is 1 for wherever it says x in the equation, and we just use our pre-algebra skills and evaluate this expression. 1 squared times 5 is 5, negative 10 times 1 is negative 10, plus 3 will eventually give us negative 5 plus 3, which is negative 2. That's our vertex. All right, graphing. 17 or 18 are both equations that have no bx to them, so we know that b value in the vertex, negative b over 2a, is going to be 0. Therefore, they always start at 0 on these, right? And then I substitute 0 into the equation, and I just get 3. I do points that are bigger, points that are smaller, and I solve for whatever those values of x are because it says y equals. So when I put in 1, I get 1 squared minus negative 1 plus 3 will give me 2. when I get 2, 2 squared is 4, times negative 1 gives me negative 4 plus 3, which is negative 1. That should be negative 1, sorry. And then I graph my equations, right? Okay, good, it's on there. Oh, right there, kind of startled me. All right, so then I label my axis of symmetry as 0, and my vertex 0, 3, and this is going to be a maximum, and y can be equal to or less than 3. On number 18, again, we see that there's no bx, so that's going to be 0. Substitute in, we get negative 5. Do points that are bigger and points that are smaller. And of course, we mirror those points. Don't forget that this gets to mirror over here, and this gets to mirror over here. And then we graph those points and label our beautiful quadratic parabola. We see the x is 0 again, and the y value shows us a minimum because it's positive, and it can be negative 5 or bigger. All right, on number 19, graphing these equations. So first I have to find my vertex, negative b over 2a. I substitute in, I get 2 for the x value, and I substitute to solve for my y value. And I see that it's going to be 7. So 2, 7 is going to be my vertex. I do points that are bigger and points that are smaller. I love that 0 is one of those points because it's so easy to solve when x is 0. It's just the c value, and then I know it mirrors to the other one. I'm going to go ahead and choose to solve for 1 and mirror that to 3, and I graph all my points. This is a negative parabola, and it graphs to be a negative parabola, so I know that it's looking correct. X is 2, and y is a maximum of 7, so it can be y is equal to or less than 7. Number 20, I also do negative b over 2a. I see it's positive. I already know it's going to make a happy face. I find my vertex. I substitute, and I find my points. I do points that are bigger and points that are smaller. Again, I get a 0, which is nice, so that mirrors to the other point. Then I substitute in for 1 because that's such an easier one than doing negative 3. And I end up with 4, and that mirrors. And I graph my points. It's positive, and it graphs to be positive. I label my axis of symmetry. It's negative 1. And my y value is a minimum of 4 or greater than 4, negative 4 or greater than negative 4. Okay, on to the word problems. So we see that we are doing falling stuff again. I'm not going to do the last 2 problems. I'm not going to have anything on the test like that for you, but we're just going to look 4 of these problems when they're real, when you're talking about height in motion, right? Where we have this equation right here. We're always talking about height of time, and it's negative 16t. This is our gravitational pull right there. This is our velocity in time, or our speed, and c is always the initial height, or where did it start off. So our equation y equals ax squared plus bx is going to change a little bit to be h equals a, and then times squared plus b times time, plus again c is just that initial height. All right, so our first equation is a baseball player hits a pitched ball when it's 4 feet above the ground at an initial upward velocity of 80 feet. How long will it take the ball to hit the ground? So the height again and the time is this way. It starts off at our c value of 4 feet, and it's going to get hit at 80 feet per second. And we already know the gravitational pulls on that. We are going to set this equation to equal 0 because we want to know when it hits the ground, when the height is nothing, right? So we go ahead and solve by factoring. I'm going to take out a GCF, but I'm starting to wonder if I can even factor this. If I take out a GCF, what happens? I end up with this AC method that does not look like it is factorable, because there are not 2 terms that multiply to be negative 4 and add to be 20. So I'm not going to use AC method. I've got to use my quadratic formula, which is okay. We know how to do this. X equals negative b plus or minus b squared minus 4ac all over 2a. Go ahead and substitute our values in. I'm going to do it again on the next slide. So you can see the original equation and when we substitute in. Now I just need to PEMDAS correctly, right? I have negative 20 plus or minus 20 squared is 400. And then negative 4 times 1 is going to be a positive 16. So I need to add 16 to that 400, and then I'm dividing it by negative 8 because the a value is negative 4. I go ahead and add that out. I get 416, and I square root that, and I get negative 20 plus and minus 20.4 divided by negative 8. When I do the first value, 20 plus 20.4, I end up with 0.4 divided by a negative 8, which gives me a negative half of a second. And I can't have a negative half of a second, so I know that's probably a non-solution. So I go ahead and trust the process and try for the next one. Negative 20 minus 20.4 divided by negative 8 gives me negative 40.4 divided by 8, which gives me a positive 5.05 seconds, which will round to 5.1 seconds, which makes sense. If you hit that ball going that fast, it's probably going to take a few seconds before it hits the ground. All right, a flare is launched from a boat. So I'm just going to redraw this a little bit. We're talking about 100 feet in the air, so I'm going to make my line just a little bit taller than it was. Okay, so I have this boat, and a flare is being launched out at an upward velocity at 80 feet per second, and it's 4 feet above the water or from the boat, right? And I want to find out how many seconds will the flare be 100 feet above the surface. So let's talk about this for a minute. When I set the height to equal 100, right? This is going to be my equation, negative 16t squared plus 80t, that's our speed, and 4 feet is the initial height. I'm setting it to equal 100 feet. So I go ahead and find out. When I go ahead and solve when that equals 0, the only way to factor it, I'm going to take out a GCF of negative 16. When I do that, I see this equation that I can easily just do an X box. It's amazing how it goes from hard to easy pretty quick. Two numbers that multiply to be 6 and add to be negative 5 are going to be negative 2 and negative 3, which tells us we have solve when that equals 0, which is going to be 2 seconds and 3 seconds, right? So which is correct, and how does it all work out? Well, let me draw this back out for you real quick. And we'll see that when it goes up in the air and it first hits 100 feet, it's at 2 seconds. And then it goes up above that, and then it starts to come back down and hits the other marker of 100 feet at 3 seconds. So if you think about how long it's in the air above 100 feet, it's going to be 1 second because it starts at 2 seconds and then it comes back down below it at 3 seconds, right? So you could say that there are 2 times for it. The flare first hits 100 feet at 2 seconds, and then it hits 100 feet again at the 3rd second, right? So 2 times that it hits 100, but you could also just say that it's been above 100 for 1 second. All right, a basketball player shoots a basketball. When it releases, they must be younger because when they release the ball, it's 6 feet in the air, right? So that means that if you're 6 feet tall, then when you release a ball, it's more closer to like 8 feet. So this must be someone that's littler, like 4 feet tall. So it must be a shorter basket. I'm going to assume it's like an 8 or 9 foot basketball height because anybody who plays upper division, they're going to play with a 9 or 10 foot basketball. But this is going to be between 8 or 9 feet, something like that. And here we go, this person's shooting, it releases at 6 feet in the air. And the question is, when will it hit 10 feet? Like when's that going to happen? And we already know it's going to happen twice, right? Because it's got to go arc above, and then to be able to get into the basket has to go above 9 feet. So it's going to have to go hit 10 feet twice. Let's go ahead and write our equation though. We have our negative 16t squared. That's our gravitational pull. Velocity is 20 feet per second, and it starts off at 6. We're going to ask when it equals 10. When it equals 10, and I go ahead and solve for that, making my equation equal 0, moving the 10 to the other side, taking out a GCF, and then I see that I do have an AC method that I could do on this. Multiply my A and C, two numbers that multiply to be 4 and add to be -5 are going to be -4 and -1. And I factor by grouping, bringing down my A and my C, and then my two middle terms. Then I take out a GCF, and I take out another GCF, and I regroup, and I solve when they equal 0. So I'm going to end up with adding 1, dividing by 4, getting 1/4 of a second, and adding 1. So again, what does this mean? How do we figure it out? Let's go back to our original drawing. We go back to our original drawing, we can see our basketball hoop, that the pathway of the basketball is going to hit the 10-foot marker twice. When it goes up into the air, that's at 1/4 of a second, and as it comes down to go swish through the hoop, it's at 1 second, right? So on the up, it's 1/4 second. On the down, it's 1 second. All right, number 4, last one we're going to look at here. In slow pitch softball, the pitcher pitches the ball to the batter with a high arc. And suppose the ball leaves the pitcher's hand 2.5 feet above the ground with an upward velocity of 27 feet per second, and the batter hits it when it's 3.5 feet above the ground. How do we solve for something like this? So we know it's going to... Okay, so let's talk about this slow pitch. Sorry, the air conditioning people came in to fix it. So let's talk about these, the slow pitch softball player. And so the ball is being pitched. I'm going to go ahead and say the ball is being pitched from the y-axis because it's the beginning. It releases from, and it's a slow pitch, so it's like this high pitch in the air. And it's going to release the pitcher's hand at 2.5 feet above the ground, because they kind of slow it down by their thigh kind of, and then would come by their knee. And then they throw it up in the air and it comes back down. It gets hit at when it's 3.5 feet above the ground. What does that mean? This ball is then going to take off, right? It's going to go back at the pitcher and hopefully go for a really long time, right? That's the goal. So let's see what happens in this scenario when I use my equation and substitute in correctly. I see that the height is still -16t squared. My velocity is 27 feet per second, and they don't throw very fast because it's like a pitch up in the air. And then its initial height is at 2.5 feet. That's when it releases the pitcher's hand. We're finding out it gets hit at 3.5 feet. How long does it stay in the ground for, right? How much time lapses between the pitch and the hit? Well, let's find out what these two things are. When they equal 0 is our first thing. So we have to get it to equal 0 in order to factor it out. I can see that I can't use Xbox because there's not two terms that multiply to be 16 and add to be 27. So I know I'm going to have to use our quadratic equation, which is fine. Negative b plus or minus b squared, 27 squared, minus 4 times a, which is -16, times c, which is -1. And we just need to do the PEMDAS correctly, right? In this scenario, we're going to see a negative times a negative times a negative. So we're actually going to be subtracting 64 because it's -4 times -16 times -1 gives us -64. We go ahead and subtract that, and we're going to divide it by -2 because 2 times -1. I'm going to give myself a little room here and erase. So then I go ahead and do the math here, and I see the square root of 665 is going to be 25.8, and I do negative 27 plus that, and I get half, like 0.6 of a second. That is when it leaves and how long it's going to take for it to get hit by the batter. When I plug in the next value, the negative, again, have to make some room for myself, I get 26.4 seconds, because negative 27 plus negative 25 divided by negative 2 gives me 26.4. And that's how long that ball is going to be in the air until it finally lands later. This is a really great hit. Maybe it does some bounces or whatnot, right? So this is how long it's going to be in the air until it's hit, though, right? That's the question. It's a little less than half a second. All right, the word problems that you have on the test, though, will be much easier. Make sure you know, if you understand how to use all these formulas, how to set up and substitute in, you will do just fine. See you in class.